Hey everybody, I thought that we would do one of the 6 problems on that little strip of worksheet together to get you going. So on your notebook paper, go ahead and title it IP 1-10, Finding a Derivative. And as I scan these 6 questions, I think I'm going to pick on problem 18. The reason for the weird numbering is they're coded for the textbook page 104. Okay? And they're also coded for the additional worksheet you picked up on the way in today as well, and we'll talk about that in a minute. All right, so our objective for number 18 is to find the derivative of 1 minus x squared. So I'm going to kind of do things kind of maybe backwards here, I guess. I'm going to put the function I'm working with over here on the right-hand side of my paper, if you would do the same. Okay, then I'm going to come back over here, and I know I want to find the derivative of this function, so I'm going to go ahead and set up the formal definition of a derivative, the long way to find a derivative. Yes, there's going to be a shorter way, but that'll be next week. So to find the derivative, we're finding a limit of secant slopes. And I've chosen to use delta x. H would be appropriate too, but I'm going to go ahead and use delta x. So in that formula that we want to take note to memorize, we have f evaluated at x plus delta x minus the y value at x. So difference of y's over difference of x's. I notice over here that I have the function, so what I'm going to be able to do is I'm going to be able to substitute in for f of x 1 minus x squared. But I need something here to insert for this functional notation. We can't perform operations on functional notation. I can't add or subtract, multiply, or divide with functional notation. So what I'm going to have to do is find a replacement. So come over here and let's create what we need. We need f evaluated at x plus delta x. So in the f function, everywhere you see x, replace it with x plus delta x. Okay, let's come back over here and set up our difference quotient. Okay, bring down the limit statement. So in the 6 problems you turn in, make sure that your limit statement is always right here in front of your secant slope. Okay, so for this expression right here, we're going to insert 1 minus quantity x plus delta x squared. I'm here at the subtraction sign. I need to insert f of x. Now be careful, you'd want to put that in parentheses because you're subtracting both terms. Okay, so we obviously have some algebra to do here. Woo! Not good. All right, 1 minus, okay, so what I'm going to do is I'm going to tackle squaring this binomial. So x squared plus 2x delta x plus, that would be delta x squared. Ooh. Minus, I'm going to go ahead and distribute this minus through, so it's minus 1 plus x squared all over delta x. Okay. I haven't used the limit part of my problem as of yet, so that still comes down. Ooh, that's a little bit better. Okay, let's distribute the subtraction sign through here. So all the signs change, minus 1 plus x squared. Okay, so now at this point we can start to clean up the numerator. Noticing that the remaining terms all have a common factor of delta x, so I'm going to factor that out so I can divide it with the denominator. Okay. So in all of the problems that you do on this little strip of this worksheet, make sure that you're bringing limit down until you actually insert 0 for delta x. So delta x taking out of this would be negative 2x minus factoring out here of this term, negative delta x all over delta x, and as we can see, those will cancel. Okay, so at this point I can clean it up and rewrite it again, or if I want to, I think at this point we can just stop. Insert the 0 for delta x. Oh goodness. Okay, what's happened? Okay, so let's go ahead and insert 0 for delta x. I'm thinking that should have canceled. Maybe I cleaned up too many things. Right. Inserting 0 for delta x gives negative 2x. So that's actually your derivative, your slope formula. Okay, so you're going to do that 5 times for the 5 remaining questions on that little strip. Okay, so now put in front of you the extending page 104 worksheet. And what I want you to notice is that this is problem 17. It corresponds to the question on your little strip. Okay, look at this one right here in the middle of the page. Okay, this has problem 18 on it, and that corresponds to the problem that we just did. Okay, so let's do one of these together so you know how this worksheet should be handled. If you don't finish this one in class, you can turn it in on Monday. Okay, it says write the equation of the tangent line to the curve given by, and here's the function, at each of the following x values. Well, I had you find the derivative for 18 so that we could actually find these equations of these tangent lines here. Okay, so you've already found the derivative. We don't have to do that again, okay, the long way. You just have to write it down. Okay, so if you look back up here at this group of problems, notice what's being requested of us. Okay, so come down here and for number 1, let's write the derivative that we found. Okay, so the derivative, correct notation and everything. Don't just put down negative 2x, put f prime of x equals negative 2x. Underneath that, the tangent slope. Well, the tangent slope at x equals 0, correct notation, would have us insert 0 for x here, here, and calculate it. Well, I can see that that's 0. This is an interesting one. If the slope is 0, then we know we have a certain kind of line. All right, now the third thing requested is a point. Well, what point? Well, the point where x is 0. So let's write the notation this way. X is 0, we want the y at 0. So that's the functional value at 0. Okay, so just a little bit of work here, 0, comma. Well, that means go back to the original problem and evaluate it at 0. So f of 0, 0 here, is 1. Now we have everything we need to write the equation of the tangent line. That's our ultimate objective. To write the equation of the tangent line, we needed slope, which is 0, as indicated by this notation. We needed a point, an x and y coordinate, that we got right here. All right, so the point slope formula. You don't have to write this down every time, but I thought I'd just at least put the formula right here one time. All right, so y minus 1, slope of 0, that's alternate notation. We're used to seeing it as m, but in calculus now we see it as a prime notation. So it's 0 times x minus 0. Okay, so this all is going to go to 0. So our final equation is 1 minus 0, or if you want to, we can call this y equals 1. And think about that for just a minute. That's a horizontal line, and the slope of any horizontal line is 0. So it makes sense that our answer should be the equation of a horizontal line, y equals 1 here. So that's kind of an unusual situation. But I just wanted to model for you what's being requested of you on this worksheet right here. So again, you've already found the derivative for each of these 3 problems, so you don't have to go through that long way. So the first step over here would be, again, to write down the same derivative. Okay, but here's where the problem starts to vary. In problem 2, you're inserting 1/2 to the derivative to get the slope. Your x-coordinate here is going to be a half. You have to plug it in here to get the y value that belongs with it, and then you can write the equation of the tangent line. So I just wanted to give you a little bit of help with both those worksheets just to make sure that you can kind of quickly progress through them. So good luck.